Welcome everyone to my YouTube channel. Today we'll discuss about the practical implementation of the KNN K nearest neighbor algorithm. And this algorithm can be used for classification problem and can be used for regression problem. Today we will show the practical implementation on the regression problem, but it can be used on the classification problem also. Okay. Now, the most important thing for the KNN algorithm is identifying the correct K value, because if the K value is not correct, then there is a chance that it might go for over predictions or under predictions, something like that. So we will use the grid search CV and identify the correct K value, and then we'll predict on the test data. That's our whole plan. Okay, let's start. Hi, so let's start. Okay. So if you are following my YouTube channel, you probably know that I already gave some practical example on logistic regression. This notebook is kind of a copy of that notebook. Only thing I'm planning to change, instead of logistic regression, we will use the K neighbors classifier from sklearn. Why I'm not changing the underlying data or any of the coding pattern or anything? Because in a data science project, it is very important to do the model selection, because the same kind of task like regression task or classification task can be done by multiple different algorithms. And it is a data scientist role to basically do the multiple experiments and then from the metrics take a decision that, okay, probably KNN is working good for this particular use case. So based on a use case, you will select the particular model. And that's why we have to do a lot of experiments. And nowadays, if you are familiar with the Databricks environment, a lot of ML flow is coming where you can track those experiments and then you can give the justification which one is the best model. Anyway, let's start. So almost all these packages are needed for this work. So I'm not going line by line, but you definitely need NumPy, pandas, and this is the main thing, which is for the KNN, which I'm taking from the sklearn package. I'm still using that breast cancer datasets, which is kind of a classification problem. We are trying to define whether the person will have a breast cancer or not. It's a 0 and 1 kind of a scenario. We need the train test split, because based on the train data, we'll do the model training, we'll do the hyperparameter tuning, and we'll find out the best K value, because that's the important part. Okay. Next step is basically we are just importing the data and we are checking what are the key components, because this is kind of a JSON format file. So we are just checking, okay, we have the data, we have the target. So we have these many other features like file name and features name, but we don't need everything. We just need data, target, target names, and the feature names. These four things are important for us. So first we are creating the data, and this data or this pandas data frame is bringing us that data frame which has the just sample 5 rows, number of features, but we still do not have the target variable, target feature. So now we are bringing the target feature into the same data frame. Now we have 31 columns. So now, as of now, it are 30 columns. Now we added the target. So basically now we have the target column present, and because it's a classification problem, that's why it's 0 and 1. Makes sense? Nothing very complicated, very simple. Again, as per the last example, we are just creating the independent features and dependent features. Then we are using the train test split, and then we are creating the X train, Y train, X test, Y test. Again, test size, we are keeping 0.25, random size 5 is every time if you do this run, it will give you the same result. Up to this, exact same what we did for logistic regression. Now, what we am doing, instead of a logistic regression, now I am bringing the k-nearest classifier from sklearn package. I already mentioned this in the top, just for here, just to show, I just mention it. There is no need to mention 2 times. And then we are bringing that particular model instance. By default, neighbor is 5. So if you are not doing any kind of hyperparameter or anything, hyperparameter tuning, what will happen? This will try to check the 5 nearest point from your test observation, okay, by default. Now, never try to memorize any of these things. If you have any such question like what is the default parameter, you can simply just do a shift tab on the Jupyter notebook and you will get a lot of information like what is the default parameters for this particular k-neighbor classifiers. Okay, classifier implementation, got it. So this step I don't need it because I'll keep this thing, so I'll just remove this 2 steps. Okay, now what we are doing, because we have to identify, but what we want to try with different k neighbors or KNN parameters, hyperparameter. This is the called hyperparameter. Remember, KNN is a non-parametric model. It is not like linear regression or logistic regression where you have the parameters. Parameters mean you have probably the coefficients for each of the variables. It is not like that. So it's a non-parametric model, but it's a hyperparameter model. So you need to tune this hyperparameter. And for that, we have a grid search CV process, and this is that logic using the grid search CV. Now again, I'm using the accuracy here also because I know my data is kind of good, so I'm using the accuracy. But if your data is imbalanced, then you have to think about different scoring parameter, probably F1 score or some other metrics. Okay, just by seeing this, I can tell that, okay, 1, 2, 3, 4, 5, 6, 7, 8, I have 8 different parameters. So that's mean if I do this grid search CV, how many times it will run? Can anyone tell me? Okay, it will run 40 times. Why? Because it has a 8 and we have a cross validation of 5. What does it mean? For each of this parameter, it will do a 5 split cross validation. So it will run basically 40 times. Okay, and then finally you will get what is the best result from this. So you can run just best parameter and best score. You will basically get your answer. Okay, and if you just create your CV underscore result into a data frame, you will get this results also. It will tell you that, okay, these are the 8 runs, and how to basically check that, okay, 8 runs, then I'm talking about 40. How is happened? Because if you check each of these hyperparameters run, like when it ran for hyperparameter 3, let's start with this. Then in this 3, it ran probably 5 times, 5 split 0, split 1, split 2, split 3, split 4, and then it find the mean of the test score. Okay, so that's very important, mean of the test score. So that's the way it's identified the best model for you with the hyperparameter. So grid search CV is very, very important when you are doing the hyperparameter tuning. Okay, now you got your best model. So now you just need to use that model and you have to create some metrics so that you can understand how your result look like. First, I created the ROC curve, which is the receiver operating characteristic curve. This curve looks very, very nice to me. And same thing again, we are predicting the data and then we are calculating the accuracy score and classification metrics. Accuracy score is looking good to me. on the test data itself is looking good to me. And then classification report, if you see, it is overall looking good because we are mainly considering the one. So all the things, recall, F1 score, everything is looking good. So this is the example of how to implement the KNN in a real life when you have a real data. Remember, I took the data from the package. That's why my life was a little easy when I showed the example. When you actually work on the real life data, you have to do a lot of feature engineering, you have to do probably a lot of exploratory data analysis, and there might be null values. You have to impute those null values. There is might be outlier. You have to remove those outliers because remember, KNN is very sensitive for outliers, very sensitive for missing data, very sensitive for huge data volume. So I think overall, if you follow this, you know how to use the KNN, and it's a very powerful algorithm. So it will give you the good results. So hopefully you like it, you enjoy it, and we'll see in the next video. Thank you so much for joining with me. If you like, please just give me a thumbs up or subscribe. I'm building so many such videos, and hopefully you will like it. Your support will help me to grow. Thank you so much. Bye.